Hey everybody, welcome back. Monty here, and we're back from spring break. Did we survive? Did we have fun? Did we finally get away from technology for 7 days? I hope so. And before we get started on trigonometry, SOH CAH TOA, I think we need to have a share out. So, pause the video, and as a class, go around the room. Did anybody go outside? Did anybody do yard work? Did anybody travel? Did anybody, go to the park? Did anybody not turn technology on for 7 days? These are just some of the questions I think that you should share amongst yourselves. Look around the room. Experience something different before we get started with trigonometry. Serious. Enjoy that. And maybe Mr. Miller will have you do a daily doodle. Maybe he'll have you do a free write. This week is about, let's share out some experiences. Maybe somebody's got a mnemonic, a rhyme, a riddle, a song about SOH CAH TOA. All right. As soon as I hear the bell, that means I want you, pause the video, share out in the class, and then come on back. Okay, got this video on, that means we're going to get going. Okay, now that may have taken 15-20 minutes, so I'm not sure how much time we have left in class. But Mr. Miller's got a handout for you, we're going to take some notes, but before we do that, I want to hopefully convince you of the beauty of math. Serious. So here we go. First of all, we did all these right triangles, right? We've got 30, 60, 90s. We got these 45, 45, 90s, these special right triangles, these square roots. What the heck is all that about? If you remember, every month or so I try to remind you, mathematics is the describing of the world with numbers. We need a way to model what is around us so that we can engineer bigger, better, taller, faster. Okay? All right. So if you look at this picture here, there's a right triangle in here. And then we got these curves. So here we go. All right, let's bring that over in the video just a little bit more. Okay. Now, as we go around the circle, we're modeling circular motion, but do you see the right triangle in the center? As it gets smaller, something happens. As it gets bigger, something happens. And it keeps pulsating. The modeling of a curve. Okay? When we go around a Ferris wheel, we model that curve. The tides come in. The tides go out. Our heartbeat. Right? We need this type of modeling of mathematics to describe real world things. And this is actually called the sine curve, the cosine curve, the tangent curve. Okay? So, we got started with our special right triangles. Our special right triangles. Okay? So that we could be introduced to this thing called trigonometry. Okay? Now, vocabulary. On the back wall, okay, we got that giant green triangle. There's a reference angle, okay? We're going to be looking at specific points, so specific vertices. That's called the reference angle. From there, we're going to have the opposite side, the adjacent side, and remember, in geometry, adjacent means next to, and then always across from the 90 degree is this thing called the hypotenuse. This only works for right triangles, and the term that we use, the function that we use to describe this relationship around the triangle is called sine. Your calculator says sin. The cosine, your calculator says cos. And then the tangent, your calculator says tan. All right? Now, we want to model this. What we're hoping to show you today is as we model, around the curve, okay, we have the sine is the vertical, the cosine is the horizontal, and the tangent. Anybody ever flown off on a tangent? Jesus, he flew off on a tangent there. Holy Toledo. A tangent is a line that touches the circle at one point, whoosh, and you fly off. So if you spin something really fast, anybody track and field, right? The hammer throw, whoosh, that's flying off on the tangent. So we have the sine part, the sine relationship, the cosine relationship, the tangent relationship. So all we want to show you today is as we describe the circular motion, as it gets bigger, comes down the other side, gets bigger, comes down the other side. Okay? Now watch the numbers this time when I go around. Sine is getting bigger, cosine is getting smaller, tangent is just kind of its own little beast. Okay? Sine gets smaller, cosine gets bigger, sine gets bigger, cosine gets smaller. It's a relationship. It's a dance. Okay? As one gets bigger, one gets smaller. One gets smaller, one gets bigger. And it's all interrelated, okay, to create a way to model circular motion mathematically. Isn't that cool? So, this is an introduction of what we're doing. We'll get into how we do it. But the why is so that we can make sense of the world. Tides, right? The tides come in, the tides go out. Okay? This circle around me right here in this video, okay? If I'm a Ferris wheel, I get on the Ferris wheel, I go up, I come back down, and we can model that, all right? And our last one, I hope everybody somewhere in their notes wrote down the website mathisfun.com. Okay? Everything geometry lives there. Now, we introduced this. Our cheat sheet has this, the hypotenuse, the opposite, the adjacent, the reference angle. Okay? We can model real-world mathematics using trigonometry. Here's what we started with just before spring break, and we told you, hey, go home over break, watch a rap, watch a song, write a rhyme, write a poem, write a mnemonic so that you could memorize SOH CAH TOA. Okay, here's some real world action. We got to learn to use the calculator. But again, here's another version of as the sine gets bigger, the cosine gets smaller, and the tangent is its own little beast on the outside as it flies off. Okay? So the numbers are a little bit kind of wonky right now. Okay? And then we finally get down to as we model the circular motion, we create what's called a sine curve and a cosine curve. Okay? The idea of periodic functions. Tides is one of the biggest examples. Okay? Alright. So, now, you had a share out. We talked about spring break. We're trying to excite you and get you interested, because in the real world, SOH CAH TOA, you're probably never going to use it unless you're an engineer. But we want you to realize that there is a way in the medical field we do trigonometry. Okay? And right now we need people in the medical field. Alright. So let's get started with another share out. Okay? Now, on your cheat sheet, it actually says what was your rhyme, song, rap, mnemonic, way of memorizing SOH CAH TOA. Again, we're going to pause the video, and hopefully this is the end of class. You're going to have 30 minutes. You're going to have like 15 of you all standing up and saying how you're going to memorize SOH CAH TOA. See you in a minute, and I'll tell you, when I was your age, what we used. Alright, here we go. Monty, when he was your age, this is all he came up with, okay? For sign, this was the rhyme that we used, and I got it from my teacher, and I still remember it, okay? Oscar has a heap of apples. Okay? That's all it was. Oscar has a heap of apples. Okay? Nothing fancy. Wasn't like those rap songs. Wasn't like those rhymes. Wasn't like those riddles. Wasn't like getting tricky with it. Okay? So, come up with yours so that you can memorize these. Because as soon as I flip the page on that note sheet, I'm going to use that every time. Okay? So again, if you have to, write this down, pause the video, do another share out, see if you can come up with one as a class. I think that would be cool, where everybody in the class uses the same rhyme. That would be fine. Okay, here we go. Grab our cheat sheets. Grab our note page. Alright, so SOH CAH TOA. Alright, we've got to know the reference angle, the opposite, the adjacent, and the hypotenuse. Alright, here we go. Today's learning. Okay, as a group, we want to learn to chant this. Okay, determine the ratio of the opposite over hypotenuse. Quick, opposite, hypotenuse. Which one? SOH CAH TOA. SOH CAH TOA. Which one? Come on, come on. Chant. Opposite over hypotenuse. Everybody. Everybody, say it. Sine. The sine, using A as the reference. So, everybody on your cheat sheet, just write ref. So the reference angle is A. Everybody, the OPP and the HYP. That leaves this for the adjacent. So, determine the ratio of the opposite over the hypotenuse using angle A as the reference, in which write your answer fractions. Here's the answer. Boom. The OPP over the HYP is 6 over 10. Pause the video. I know we're all at different levels of math skills, okay? But we can always take an extra minute to do simplest form, okay? So if Mr. Miller pauses the video now and has a discussion about how to create the simplest form, we always want a fraction, okay? We do not want 0.6. Please, no decimals, okay? And we'll get into more why that is. It's not a wrong answer. It's not what we need when it comes to trigonometry and this motion around a circle. We want the fraction, okay? So again, pause the video if you need to, but I always think of even numbers, cut them in half. 3 over 2, 5 over 2, so I cut them both in half, okay? So there's the best answer. All right, so there was a lot there. We're already 15 minutes into this video, plus you had pause time. Class might be almost over. All right, so here we go. We need the opposite over the hypotenuse. The very first thing you do on every one of these problems today, this week, after this week you won't have to do that, but I want you to circle the reference and label it. The reference angle is A. Once I know the reference angle, across from the reference is the OPP. Across from the 90 is the HYP. And that leaves the adjacent as the one that's next to. Alright? So the answer, the opposite over the hypotenuse, the OPP over the HYP. Come on, chant. OPP over the HYP. Which function is that? So, that's the sine of angle A is equal to the opposite over the hypotenuse. Okay, now I want everybody to circle that. Okay? The sine of angle A. The sine of angle A. Okay? Is equal to 24 over 26. Now, simplest form, cut in half. So now what do we get? 12 over 13. That works for this one, doesn't it? So our final answer is the sine of A equals 12 over 13. Okay? Now I'm not sure how far we're going to get because we had pause time, we had share out. It depends on how talkative everybody is from spring break. I'm going to go for 3 more minutes and then we're just going to stop. Okay? If you try the solo activity and it doesn't quite make sense, wait till the Wednesday, Thursday class, come back and try it again. Okay? We're trying to get this idea of SOH CAH TOA, this new vocabulary in our brains. That's why every time I talked about the OPP, the HYP, the ADJ, the OPP, the HYP, the ADJ. Alright? Okay. Now, as a group, we're going to chant, determine the ratio of the adjacent over the hypotenuse. Come on, everybody, look at your cheat sheet. SOH CAH TOA. Which one is adjacent over hypotenuse? Opposite over hypotenuse. Adjacent over hypotenuse. What does the C stand for? Chant as a class. Everybody. Cosine. Alright, so we're talking about cosine here. On your calculator, it's abbreviated cos. Okay, so now, reference. There's the REF. That must be the OPP. That must be the hypotenuse, the HYP, which leaves this as the adjacent. And in cosine, the cosine of angle A is equal to 20 over 25. Everybody, pause the video if you need to. Circle that. Okay? There's a lot of writing when we get to introduce ourselves. I think the easiest way is to chant as a class. Everybody. The OPP, the HYP, the ADJ. Okay, simplifying fractions is not an easy task for everybody. So again, pause the video and everybody do a little share out. What is the simplest version of 20 over 25? Okay? Alright. Spoiler alert. 5 times 4, 5 times 5. 5's cancel. 4 over 5. The simplest version of problem number 1 is cosine A equals 4 over 5. Okay? Again, if we have to, class can be over right now. I want to make sure that we all push ourselves Okay, we're finally back in the classroom. We got to do skill builders, and one of our skill builders is simplifying fractions. Okay, and it can take some time. Not all of them are just nice and easy. Cut them in half. Okay, and be proud of yourselves for trying. We're all at different skill levels, so look left, look right, and see if you can help somebody. Hey, you know how I learned? Hey, you know how I do that? Hey, I don't know how to do any of that. Practice. Okay, don't fear the mistake. Okay, embrace it. Okay, it's not fun to lift weights. All right. Speaking of lifting weights, when the COVID first hit, I started getting fat. All right, I got my weights. Okay, I got weights for my wrists. I got weights on my feet. Okay, we've got to exercise. And one of the ways to exercise numerically is simplifying fractions. Don't be afraid of it. Try it. Okay, let's do one more, and then I think we'll call it quits for the day. Okay? Thursday when you come in, we're going to have a warm-up. Okay? What the heck is going on here, right? Okay? Thursday, we'll do more as a class. So, here's our last one for today. Let's label this. Let's grab a new color here. Label the reference, the REF, the OPP, the HYP, and the ADJ. Alright, so now the cosine of angle A is the adjacent. It's the adjacent. When it comes to cosine, CAH, the adjacent, Oscar has a heap of apples. Okay. The cosine of A. Cosine of A is 16 over 34. Okay, circle it. Again, pause the video if you need to. Discuss simplifying fractions. You know, that's not my favorite number here. Let's just go like this. 16 over 34. Half of 16 is 8 over 8 over 17. Yeah, can't do any more with 17. Cosine of A equals 8 over 17. All right. Okay, we're going to see you all on Thursday. Okay, SOH CAH TOA. Don't lose this sheet. I'm challenging all of you when you come to class on Thursday. What is your rhyme? What is your mnemonic? What is your song? What is your rap? So that the letters of SOH CAH TOA make sense. Welcome back, everybody. Have a great week. Kind of getting back in the swing of school.